Video lecture is an example of how to build a basic subnetwork queuing model. And so we're going to use visual subnetwork modeling to build this. And the subnetwork will be each individual queue server combination. So this would be similar to the airline check-in problem that you had for a couple weeks ago. And we're going to build each server as a subnetwork and then invoke those servers to the main network. We've already set up the control model. This is pretty much the standard representation that you've seen in the past. So it has just the 5 basic nodes, and that's all you need. To build a new subnetwork, let's click on subnetworks and new. And so we're going to create the subnetwork. The first thing we have to do is add a VSN block to identify the particular virtual subnetwork. So we're going to call this subnetwork clerk, C-L-E-R-K, and we'll have one parameter called service time, which we will pass in. Description is service time, and this will be a double precision value. We click insert to add the parameter, have the virtual subnetwork name, click OK, and we're all set. Next thing we have to do is to initialize the virtual subnetwork. This is kind of an optional step, as I'll show you later, but in some cases you may have to do this. So we need an entry point for the virtual subnetwork, so we take an enter VSN node, give it an entry point label, which I'll call initialize, and the initialize subnetwork just will invoke an instance or copy of this subnetwork to be referenced later. So all we have to do is essentially return this entity back to the main network through a return VSN node and connect that with a zero-time activity. Next step is to actually model the actual service. So we have another entry point called service, and we're going to just use the standard queue server combination. So we'll add a queue node and file number 1. Note that Awesome creates unique file numbers for each instance, so you can use file number 1 for instance 1 and file number 1 for instance 2, or a different instance of the subnetwork, and those will be taken care of and treated independently. So click OK. Let's collect some statistics at the end of the service. We'll call this collect number 1. Tnow minus attrib 1 will be the calculation, and the time in the system will be the string that we'll use. Okay. After that, we will essentially do another return VSN node to return back to the main network. Okay, so we link all these together. So service time is a zero-time activity to send it from the entry point to the queue. Next, we have a service activity, and the duration, we'll call it exponential. But we're going to use this parameter we created in the VSN node as the average service time. So we'll put in the place where we put the average as this variable ser v time. Okay, so same thing as I put up here in the parameter for the virtual subnetwork. And then we need another node or another activity to send it back to the main network. So this will represent unique servers and queues, even though we use the same queue number. Also, the collect statistics will be unique for each instance of the subnetwork. We'll save that as, we'll call it clerk. Clerk 2 in this case. Click OK. You can call it anything you want and close the subnetwork editor. Then we'll select Clerk 2 as the subnetwork for this model. The next thing we need to do is build the network, and we're going to build kind of a two-part network. The create node will be used to initialize instances of the subnetwork. So we'll just create one transaction or one entity and call the virtual subnetwork with the entry point name initialize. The VSN name will be clerk, and the instance will be clerk 1. So this will be creating the first clerk at the service counter. And if we want to create a second clerk at the service counter, we can do this the same way. We put in initialize, VSN name is clerk, and the instant is clerk 2 for the second clerk. So we have two instances of the virtual subnetwork clerk. One of them is called clerk 1 and the second one's called clerk 2. These will be treated separately. Then we put in a terminate node to terminate the transaction, some zero-time activities to cause the flow, and the creation of these two instances of the subnetwork. Next, we want to create actual arrivals to the system, so we're going to have time between arrivals also exponentially distributed with a mean of 5. And one other thing, we want this to happen just a small amount of time, so we'll say 0.001, a small amount of time so this initialization phase gets completed. After we create the entity, we're going to send half of the entities to clerk 1 and half of the entities to clerk 2. So this will be the service entry point, and VSN name will be clerk, and the instance is clerk 1 for this entry point, and we want to send it the service time average, so we'll send it a value of 5. Second instance, we're going to create a slower server. In this case, the entry point will be service again, VSN name called clerk, and the instance will be clerk 2, and this time we'll have a service time of 10 instead of 5. Okay. After that, we're going to collect statistics on all of these entities that flow through the system. So this will be collect 1, value will be t now minus attrib 1, and that'll be time in the system. Okay, we'll resume this discussion in the second video lecture.